Welcome to ClickMyProject.com. Now we will discuss about regional grain yield response to climate change in China, a statistic modeling approach. A model variation plus uncertainties in future climate change scenarios create a big challenge for such evaluation. In this work, we developed a statistical models for 6 different regions in China using a historical yield data between 1981 and 2010 from National Bureau of Statistics combined with meteorological station observation and analyze the impact of climate variation, that is temperature and precipitation changes on the grain yields into 2030s based on 28 ensemble climate predictions from 6 state-of-art coupled model intercomparison project phase 5 model outputs. Our results indicate that the 4 crops rice, maize, wheat and soybean respond similarly to climate variation in different regions of China, with the sensitivity to warming increasing from north to south and from inland to coast regions. In addition, the yields of all 4 crops in east and central south China also positively correlated with precipitation change. This is the flow of our process. First of all, we have selecting the input data set. After that, we have uploading into the distributed file server. Then the uploaded content should be applied to pre-processing. In pre-processing step, raw data is converted into understandable format. The data pre-processing means one of the data cleaning step in data mining. This reduces the garbage volume from raw data set and stored into a relational database. After that, calculating the average temperature using maximum and minimum temperature value. Then we have calculating the average precipitation. Then we have calculating the correlation between temperature and precipitation value. Finally, we have predicting the crop and yield response. Now, let us see the demo of our project. Our project title is Regional Grain Yield Response to Climate Change in China, a Statistical Modeling Approach. First of all, we have to run data selection.java. First of all, we have to select the input data set. This is the content of the input data set. The input data set contains the number of attributes such as crop type, country, observed yield, area, seed amount, years. This is the input data should be the raw data. Then we have applying the raw data into understandable format by applying the pre-processing. In pre-processing step, the raw data is converted into understandable format. That means the raw data is cleaned and stored into relational database. Pre-processing is one of the data cleaning technique used in data mining. The data is pre-processed. The pre-processed data is displayed. There are 6 attributes in this relational database and number of records. Then we have pre-processing the climate dataset. First of all, we have pre-processing the crop dataset. After that, we have pre-processing the climate dataset. So the climate dataset contains the crop type, country, observed yield, area, seed amount, years, and temperature, maximum temperature and minimum temperature, precipitation, and month. After that, we have calculate the average temperature from maximum and minimum temperature. This is the average temperature we have calculated. Then we have calculating the average precipitation. This is the average precipitation value. Then we have calculating the correlation between temperature and precipitation. This is the correlation between temperature and precipitation for particular country and crop type. Then we have selecting the correlation value, for example 0.017, and select this is the predicted crop type and country based on selecting the correlation value. And then we have finding the correlation between observed yield. So in this process there is no observed yield find between selected crop type. Thank you.